what is the problem? The complex roots, of course, there will be two roots, and they're complex conjugates of each other, so they'll be of the form a plus or minus bi. Last time I showed you I took the root r equals a plus bi, which leads to the solution. The corresponding solution is a complex solution, which is e to the a t a plus I bt. And what we did was, the problem was to get real solutions out of that. We needed two real solutions. And the way I got them was by separating this into its real part and its imaginary part. And I proved a little theorem for you that said both of those give solutions. So the real part was e to the at times cosine bt, and the imaginary part was e to the at sine bt. And those were the two solutions. So here was y1, and the point was those, out of the complex solutions, we got real solutions. We have to have real solutions because we live in the real world. The equation is real. Its coefficients are real. They represent real quantities. That's the way the solutions, therefore, have to be. So the point is, these are now real solutions. These two guys, y1 and y2. Now, the first question almost everybody has, and I was pleased to see that at the end of the lecture, a few people came up and asked me, yeah, well, you took a plus bi, but there was another root, a minus bi. You didn't use that one. That would give two more solutions, right? Of course, they didn't say that. They were too smart. They just said, what about that other root? Well, what about it? The reason I don't have to talk about the other root is because although it does give two solutions, it doesn't give two new ones. Maybe I could indicate that most clearly here, even though you won't be able to take notes, by just using colored chalk. Suppose instead of a plus bi, I'd used a minus bi. What would have changed? Well, this would now become minus here. Would this change? No, because e to the minus ibt is the cosine of minus b, but that's the same as the cosine of b. How about here? This would have become the sine of minus bt, but that's simply the negative of the sine of bt. So the only change would have been to put a minus sign there. Now, I don't care if I get y2 or negative y2, because what am I going to do with it? When I get it, I'm going to write y, the general solution, as c1 y1 plus c2 y2. So if I get negative y2, that just changes that arbitrary constant from c2 to minus c2, which is just as arbitrary a constant. So in other words, there's no reason to use the other root because it doesn't give anything new.